Good day viewers, you are welcome to my YouTube channel. This is Chem Easy and I'm Echo Jeremiah. Please, if you've not subscribed to my YouTube channel, do that now by hitting the subscribe button. That's the only way you can appreciate us for our hard work. Please, thank you for doing that. You can comment, you can like, and also share this video. So you have requirements for the practical, for the titration. It says 150 cm³ of Tetraoxosulphate 6 acid in a bottle labeled AN. The acid solution, which should be the same for all candidates, will contain 3.8 cm³ of concentrated sulfuric acid per dm³ of solution. YB is 150 cm³ of sodium triocarbonate 4 solution in the bottle labeled BN. This solution, which should all be the same for all the candidates, will contain 6.00 grams of sodium carbonate per dm³. So now, this titration is between Tetraoxosulphate 6 acid and sodium carbonate, which is sodium triocarbonate 4. Alright, it's kind of an acid-based titration, but take note, sodium carbonate is a salt, or precisely we say is a basic salt. Alright, it's a salt, but it has some basic properties. This is because it is formed from the neutralization of a strong base, which is sodium hydroxide, and a weak acid. Alright, which is carbonic acid. Okay, so when these two react together, you have sodium triocarbonate and water. Alright, so this is how it is formed. It is formed whenever a salt is formed from a strong base and a weak acid. This salt formed, though it's a salt, it will have some basic properties. Alright, so sodium triocarbonate 4 is a salt, but it has basic properties. So this kind of titration is more or less an acid-based titration between Tetraoxosulphate 6 acid and sodium carbonate. Okay, and to also confirm this, when sodium carbonate dissolve it in water, it exhibits basic properties, which is that is, it hydrolyzes. Once dissolved in water, it hydrolyzes to give sodium ion, bicarbonate ion, and hydroxide ion. Okay, so it is the presence of this hydroxide that gives it that basic property. All right, so now we will go back to the preparation of the reagent. All right, the first one A says we should measure out 3.8 cm³ of sulfuric acid, all right, and dilute it to 1 dm³, that is per dm³. And take note, 1 dm³ is equivalent to 1000 cm³. All right, so now let's go over to the preparation of this solution. So we'll begin first by measuring 3.8 cm³ of the acid using a measuring cylinder, and then we'll add a little volume of water to a 1000 cm³ standard volumetric flask, to about half of it. First, take note, you add acid to water, and then you add the acid to the water. You can rinse the leftover acid properly and gently into the standard volumetric flask, and then you dilute to the 1000 mark with distilled water. So here we go, and then you turn to your volumetric flask, that is 150 cm³ of it. Alright, now how do we calculate the concentration of 3.8 cm³ of Tetraoxosulphate 6 acid in 1 dm³, which is 1000 cm³? Alright, so now this is how you do it. You use this dilution formula, which is C1V1 is equal to C2V2. Alright, where C1 is your initial concentration Your V1 is initial volume. Your C2 is final concentration. And your V2 is final volume. All right, so now here is the where most teachers especially find it very difficult is getting the initial concentration. How do you get the initial concentration of your stock solution? It's a very simple thing. Now, for you to do that, you must know three things. Take note. We want to calculate the initial concentration of tetraoxosulphate acid. First, you must know the formula weight. The formula weight, which sometimes they call it molecular mass, but we don't use molecular mass for it because it's kind of an ionic substance. So we use the word formula weight. All right, the formula weight for sulfuric acid, you should know it. Also, you should know the specific gravity. The specific gravity of sulfuric acid, and then you know the percentage concentration of the original stock solution. Now, this is how you do it. If you have your Winchester bottle like this, you can get those information here. Now, when you look at this very well, you see 98%. This tells you the percentage concentration of this stock solution, that it is what? 98% weight by weight. Okay, now when you see the word 98%, this is how you interpret it. It means, take note, percentage is over 100. It means 98 grams of the acid, which is diluted to 100 grams with water. In other words, this solution contains 98 grams of the acid, then 2 grams of water altogether to give you 100%. Take note, the reason why we are using grams because it is weight per weight. Okay, sometimes you can see it as 98% V per V, which means volume over volume. Okay, but take note, we are going with grams per gram, so that's how you interpret this. So ensure you check this on your Winchester bottle. Some of you might see 96%. All right, if you see 96%, it means the stock solution, the initial concentration is 96 grams of the acid diluted to 100 grams with water. That is, we are having 96 grams of the acid and 4 grams of water to give us 100%. All right, so take note of that. But in this case here, we have 98%. So that is the original concentration, the initial percent concentration, which we have it as 98 grams of sulfuric acid, which is diluted to 100 grams with distilled water. All right, now the specific gravity of sulfuric acid, you can check that online, is 1.84 grams. All right, so this is the specific gravity of sulfuric acid, 1.84 grams per cm cube. All right, and then the formula weight for sulfuric acid is always on the bottle. You can see it here, written here. Here it is written molecular weight, but precisely we use the word formula weight. It is 98.07 grams per mole, which is more or less, most people will say, the molecular mass, but the right word to use is the formula weight. All right, so here we are having 98.07 grams per mole, which is the unit. So 98.07 grams per mole. Now, with these three information you have here, you can calculate the molar concentration of the stock solution by doing this. Just follow this simple step to do that. All right, so here we have the percentage concentration, which is 98 grams of the acid over 100 grams of water. You multiply it with the specific gravity. Now, when you see this specific gravity, it says 1.84 grams per cm cube. All right, that means for every cm cube, the specific gravity is 1.84 grams. So we multiply it with it, 1.84 grams over per cm cube, which is 1 cm cube or cm cube, still the same thing. All right, so now what you do now, you multiply everything together. Take note, grams, we cancel this. So 98 times 1.84, you have 180.32 grams over 100 times 1 cm cube, you have 100 cm cube. Okay, so now we're having 180.3 grams over 100 cm cube. Now, how do we convert this into molarity? Take note, molarity, which is concentration, which is our molarity we are looking for here now, is equal to amount, which is calculated in moles, over volume of solution in dm cube. All right, so now let's start by calculating amount. Let's convert this 180.32 to amount. Okay, amount, which is mole, is equal to mass over molar mass. All right, now what's the mass we're having there is 180.32 grams over the molar mass, which is the formula weight here, which we have as 98.07 grams per mole. All right, so we're having 98.07 grams per mole. All right, so grams cancel grams, all you have is approximately 1.84 mole. All right, so we've gotten our amount to be 1.84 mole. All right, so now take note, the from just a preview of what I've been doing so that it follow up. I said concentration is amount, so we converted this mass we got here to amount. Now we'll also convert this, we're taking it in cm cube, but your volume in your molarity formula is in dm cube, so you convert cm cube to dm cube. All right, it's just a simple relationship. 1 dm cube is equivalent to 1000 cm cube. All right, then 100 cm cube now will be how many dm cube? All right, cross multiply to give you 1000 times s, give you 1000 s. 100 times this one gives you 100. All right, so when you divide both sides by 1000 to get s, all right, s becomes 0.1 dm cube. All right, so the volume here, we've converted it to 0.1 dm cube. Excuse me. .1 dm cube. So when you divide this together, your final answer is that's 1.84 moles divided 0.1 dm cube. You have approximately 18.4 moles. So this is the initial concentration of the sulfuric acid. Okay, so take note of this. You don't need to do all this calculation. If you check the Winchester bottle and the acid there, you see 98%, it means the initial concentration of that stock solution is 18.4 mole. But if you see 96%, it means the initial concentration, that means you are replacing 98% with 96. If you do the calculation, you should be having 18 moles. So ensure you check your Winchester bottle very well to see the percent concentration there. All right, but most stock solution of sulfuric acid always comes in 98% concentration. So our initial volume, as we've just calculated here, which is C1, is 18.4 moles, and our initial volume, now take note of what we asked to prepare. They said 3.8 cm cube of sulfuric acid in 1 dm cube. Okay, so our initial volume, this is the initial volume we want to measure out from the stock solution. All right, so here we're having it as 3.8 cm cube, and our final concentration, that is what we are looking for. And V2, we are diluting it to 1000 cm cube. Take note of that. So here becomes 1000 cm cube. All right, 1 dm cube means 1000 cm cube. The reason why we are using cm cube because our volume here is in cm cube, so it's good we go with cm cube here. All right. Okay, so we substitute this into the formula. C1V1 equal to C2V2. Your C1 is 18.4 mole times your V1 is 3.8 cm cube equal to C2 times your V2, which is 1000 cm cube. So we make C2 the subject of formula. You have 18.4 mole times molar rather 3.8 cm cube over 1000 cm cube. All right, so once you divide this, you have 0.0699 mole. This is the concentration of the acid. All right, ensure you leave it to 3 significant figure. Okay, so this is the concentration of the acid. So all right, we'll go back to the B part of it. Now the B part of it says 6.00 grams of sodium triocarbonate 4 per dm cube. All right, so that means we are having 6.00 grams per dm cube. All right, per dm cube is equivalent to 1000 cm cube as usual. All right, so now the reagent is this, and this is the molar mass of it, and the required gram we are to weigh is 6.0 grams. So we'll go over to the preparation of it, and thereafter we'll calculate the concentration. So we'll start by weighing 6.00 grams of sodium carbonate. First, we'll start to reduce it to 0. Then we'll add carbonate 4 gradually till we get to 6.00 grams. And we're almost close. Here we go. And thereafter we add water to it. We dissolve in water. You stir continuously to dissolve properly. After this, you add little volume of water to your standard volumetric flask, 1000 cm cube capacity, like half of it, and then you add the sodium triocarbonate 4 to it. You may want to rinse it to ensure all the soft particles are well transferred into the 1000 cm cube flask. There we go. And then we dilute it to mark using distilled water. Alright, so here we go, and then into our reagent bottle. Alright, now so if we dissolve 6.00 grams of sodium carbonate in 1000 cm cube, what then is the concentration? All right, to do this is very simple. We say concentration is equal to amount, which is in moles, over volume of solution, which is in dm cube. All right, so now let's start first by calculating looking for the amount. Then we'll come over to look for the mole. All right, so you know amount is calculated as mole is equal to mass over molar mass. And what's the mass? It is 6.0 grams, 6.00 grams. And what's the molar mass, which is the formula weight? We use the word formula weight because it's an ionic compound, okay? The formula weight of sodium carbonate. Excuse me. The formula weight for sodium carbonate, we have it here as 105.99 grams per mole. 105.99 grams per mole. So we have 105.99 grams per mole. All right. When you divide this, you have 0.0566 mole. All right. So our amount here is 0.0566 mole. All right, now the volume says per dm cube, which is 1000 cm cube, and take note both of them are equivalent. 1 dm cube, we say it is equivalent to 1000 cm cube. Okay, take note our formula here is in dm cube, so we use the dm cube, okay, which is equivalent to 1000 dm cube. That means it is over 1 dm cube. All right, so once you divide these together, you have 0.0566 mole per dm cube. So this is the concentration of Bn. All right, so in summary, our An, which contains our tetraoxosulphate 6 acid, has a final concentration of 0.0699 mole per dm cube, and our Bn, which contains sodium trioxocarbonate 4, has a final concentration of 0.0566 mole per dm cube. So now we'll go over to calculate the theoretical endpoint of this titration. All right, now for you to get the theoretical endpoint of this reaction, first we need to get a balanced chemical reaction. Now this titration is between sulfuric acid H2SO4 is aqueous plus sodium trioxocarbonate 4. Sodium trioxocarbonate 4. All right, which is aqueous also. Now, this is one property of an acid. Whenever an acid reacts with a carbonate, it gives you the salt of the acid, which is sodium tetraoxosulphate 6 salt. All right, it gives you water, and then it gives you carbon dioxide gas. So please take note of this. You can check if the equation is balanced. The equation is balanced. So this is the equation for the reaction. So now to get the theoretical endpoint, we use our CAVA over CBVB equal to NA over NB. All right, so now let's go over to imputing the parameters. Ca is the concentration of the acid, which we got as 0.0699 mole per dm cube, and Va, which is what we are looking for in this titration. All right, which is the endpoint, the average volume of the acid used, because this is the one that will be in your burette. All right, so we are looking for this one. Our Cb, which is the concentration of the base, is 0.0566 mole per dm cube, and our Vb is the size of the pipette. All right, so you should be, depending on the size of pipette you are using, if your screw is using 25 cm cube, you should use 25 cm cube. If you are going with 20 cm cube, you should also please take note by indicating that. All right, so here we are using 25 cm cube as the volume of our pipette. The Na is the number of moles of acid. The number of moles of acid here is 1. We have just one molecule of tetraoxosulphate acid, which is 1, and also Nb, which is your basic salt here, is also 1 mole of it, so we have it as 1. All right, so now we'll go further to substitute this into the equation. We have CAVA over CBVB equal to Na over Nb. So when we substitute this into the equation, we have Ca, which is 0.0699 mole per dm cube, times the Va, which is unknown. Then your Cb is 0.0566 mole per dm cube, times the Vb, which is 25 cm cube, times Na is 1 over 1. So we cross multiply now. So equal to 1 over 1. So when we cross multiply, we have 0.0699 mole per dm cube times Va times 1 gives you same thing. Then also this one 0.0566 mole per dm cube times 25 cm cube times 1. Alright, so we'll make Va the subject of the formula by dividing both sides by the coefficient of Va, which is 0.0669 mole per dm. So we have Va is equal to 0.0566 moles per dm cube times 25 cm cube over 0.0699 mole per dm cube. Alright, so when you divide this together, you have 20.24 cm cube. So this is the endpoint. Whenever you want to conduct your titration, ensure the endpoint, which is the volume or the average volume of AN used, the sulfuric acid, should fall within this range. So now let's go over to the titration to confirm this. So we start first by filling our burette with the AN, which is sulfate 6 acid, to the 0 mark, and then you adjust, take readings at the meniscus, and our AN into our beaker. Then we pipette 25 cm into the conical flask. That's the first one. And we pipette another 25 cm into the other conical flask. Thereafter, we add 2 methyl orange. And then you titrate with your AN until you get to the end point. The end point is judged by first permanent orange color. Alright, so this is the end point. If you compare it, you see the first one is golden yellow, while this one is orange color. If you check the volume of AN used, I think it's around 19.80 from here clearly. Alright, you can repeat the titration with the other 25 cm cube inside the conical flask. Fill your burette to the 0 mark with your AN. You titrate with the 25 cm cube of your BN, which is your solid 4, till you have the first permanent orange color, which is the end point of the titration, or the equivalence point where the AN is just meant to neutralize the BN, which is this. Alright, so the end point. Now if you check the average volume of AN used at 20.30. So we'll go back to recording our readings. First, you start by stating the indicator used. You indicate which is our methyl orange, and then the size of pipette. Ensure you indicate this, which is 25 cm cube, and then this is your burette reading. Alright, initial means where you started from. We started from 0.00. I started from 0.00 all through the titration. though you can continue from where you stop and ensure you indicate the initial reading here. All right, so our first reading we got around 19.80. all right, ensure your recordings is to 2 decimal places. All right, and the other one we did, we stopped at 20.30. Take note, this minus this, you have 19.80. Here we have 20.30, and when I conducted it again, I have 20.20. 20.20. You can as well manipulate this. Let's see, here we have 20.20 also. 20.20, but it's proper you conduct this titration thrice or 4 times to have concordant values. All right, so now we go over to calculate the average volume of AN, which is your sulfuric acid used. All right, you look for the closest value, the two concordant value. All right, and in this case I'll be going with this and this. I don't want to take these two things because I didn't conduct this last one, but ensure you can do that when you have enough time. So I'm having 20.30 plus 20.20. all right, since we are using just only two values, the average, we are dividing it by 2. So once you sum this and you divide it by 2, you have 20.25 cm cube. All right, so this is our endpoint for this titration. All right, so please subscribe to this YouTube channel. I'll be dropping likely questions you might see in your NECO exam, and also the qualitative analysis of it. So it's only when you've subscribed to the channel you'll be the first to get the notification when I upload that video. Thanks for watching.